Yvsira. I kind of want to preference the next three talks for a second. They do come out of my research group on election security. Yvsira, Bethlehem, and Izzy all spent summer and fall of 2020 looking at process mapping for voting and risk assessment. We then broke that project up into three smaller pieces. So you'll see how they kind of meet up a little bit, but in the back of your mind, there's some process mapping, there's some other things going on that lead into this. So if Sarah, whenever you're ready.
So, awesome. Yeah, so my project title is Leveraging Security Behaviors to Prevent Insider Threat. My advisor is Dr. Scala, as you mentioned earlier. Um, the table of contents, pretty basic stuff. So, introduction. After the 2016 election, the Department of Homeland Security revealed that 21 states were subject to attacks on their election system during the election cycle. And in July of 2019, the Senate Intelligence Committee concluded that all 50 states were targeted by the Russian Federation in 2016, which is pretty big because that's essentially all the states. And the big question that I want to answer is what can we do to prevent an insider threat? And insider threat is basically a malicious threat to an organization that comes from people within the organization. In my research, we'll be looking at poll workers. So, with that being said, my project will examine poll worker behavior with their personal computers in order to identify how to mitigate security issues and better educate poll workers. Threats to election security can occur at both the state and local levels. However, security starts at polling places, as that is where votes are casted, and thus poll workers are the first line of defense. And to talk about a little background about the data, I used CBIS, which is essentially a security behavior intention scale, which has 16 questions and with a 5-point Likert scale, which I'll talk more about on the next slide. And the goal of CBIS measures participants' intentions and how those intentions may vary. And one thing I really want to point out is CBIS does not measure or predict behavior. And this survey was given to poll workers and those with intent to serve during the 2020 elections. As a result, I received over 2,000 responses from those poll workers from 13 different states. And as you guys can see, this is the 16 questions I talked about, which are grouped into 4 sections of device securement, password generation, proactive awareness, and updating. Like I said on the previous slide, the 5-point Likert scale are never was given a 1, rarely 2, sometimes 3, often 4, and always 5. And that basically means if a poll worker answered never for question 13, that specific poll worker was given a score of 1, and so forth and so on. Um, so after the data, the first thing I did was I built the ANOVA tables using these 4 groups of state, age, experience, and comfort level to see if there are any relationships between the poll workers. After that, what I did is I singled out the p-values. One thing I want to point out is even though these p-values are 0.000, they're not true value of 0. It's just the p-values are really, really small. And that goes to show that there's significant difference among how the poll workers answer these questions. So this told me that there's definitely room for improvement because not everyone is on the same boat when it comes to these questions. After this, I realized ANOVA wasn't enough and I needed to do more. The next thing I did was Spearman correlation to see if there's any positive correlation, which also helped me build Chalu trees, which I'll talk about later. And then after that, second to last thing I built was information theory. Um, as most of you guys are aware what information theory is, it basically paired each question, like a question for each other question. So for this example, we looked at 13 against 14. First thing I did was build a contingency table, which essentially is a count and then followed by probability table and Shannon information. After that, I looked at the enthalpy and joint enthalpy. And with all that other tables, this is the most important table that gives you the result, which is essentially mutual information, which looks at information shared between two sets of data. In this instant will be question 13 and 14, 13, 16, 13, 17, and so forth. I built this information theory for each question. So with that being said, I used the mutual information and the Spearman correlation to build Chalu trees. Chalu trees finds the maximum weighting spanning tree using mutual information to calculate edge weights. And a way to read this is if you improve question 14 and question 17, will have a positive impact on question 13, which is denoted as the plus or minus sign here. In this case, both of them are plus, so they'll have a positive impact on them. And furthermore, you can use the mutual information, which is here. And I built this for all 16 questions. So now I have ANOVA tables, a Spearman correlation, information theory, Chalu tree. What does this all mean? And the best way to answer this question is by this influence diagram that I built, which is also divided into the 4 sections of how the CBIS questions are set. And I know this kind of looks like a lot right now, and a summarized version of that is by looking at the table to the right. So it was listed by CBIS questions, and this section looks at count of influence. A way to read this is, let's say if we improve question 13, it will have a positive impact on one other question, and question 14, however, will have a positive impact on 3 other questions. So as you can see, if I was an elections official or someone looking to improve any threats, I would focus on question 26, which has a count of influence on 4. And question 26 is when browsing websites, I mouse over links to see where they go before clicking them. With that being said, these are my 2 key recommendations, which is implementing a day either over the weekend or any free day that all poll workers can gather and learn more about security awareness and how they can be proactive. And my other recommendation is create a rule book / guide for strong practice, password practice for poll workers. For that, implementing a day, activities can either include how to check if a site connection is secure, or how to tell if a link is safe without clicking on it, how to check and upgrade devices to the latest software for better security. And for the rule book, they would have things like making sure all passwords have special characters, don't recycle passwords, use 2-factor authentication, and longer passwords are better and safer. And so my project specifically looked at election security, but a way to bring that to our world of supply chain is when looking into supply chain security. Supply chain security doesn't have a single functional definition. It's a massively broad area that includes everything from physical threats to cyber threats. And a great example of this is the SolarWinds data breach that happened a couple months ago. And a way a company can use CBIS is by giving their employees these questions and getting a better insight on what their intention is when it comes to security. With that data, they could better tackle these 5 topics of data protection, data locality, data visibility, fraud prevention, and lastly, third-party risk. That being said, this is my reference and acknowledgement, and I really want to say I want to give a big thank you to Dr. Scala and Dr. Dellinger for helping me out with this project. And that's it. Does anybody have any questions, comments, concerns?
Hey, yep, sir. Can you go back to your ANOVA table
Yes.
earlier? This, yeah, ANOVA,
Yep.
yes. So the purpose for ANOVA, right? Basically, you compare group means across different groups. Is that right? Are you doing here? So I see that first. So I want to understand that. So question 13 about the first one. So you have single factor. So what? That's about a state. So that's a state-based comparison.
Yes.
Right.
Yes.
So the first the quadrant. So you compared. Basically, you grouped Maryland, Minnesota, Ohio, Pennsylvania, Virginia, and some you group some other states you group into one group. Is that right?
Yes, because there was a couple poll workers that had answered one specific state. So it will be like one poll worker was a poll worker in New York, and there was
Okay.
only one data point.
So you test their response to question 13, right,
Yes.
for all these different states.
Yeah.
So given that quadrant, what is your conclusion?
Yes, so
That
I
this-
see the answer, the question you're asking me is also the question I had when I first started making the ANOVA tables. The only problem is, as you can see, these averages are pretty high. So I didn't want to do ANOVA tables per each state because I didn't want to single out, say
Here's
like
my
Maryland is
comments
better
here.
than Minnesota. Huh?
ANOVA table only tells whether the means for Maryland, I mean, among those groups, whether
Yeah,
at least one group differs from other groups in terms of mean. So it solves high or low. Actually, see that. So like say Maryland has 4.3, right? Minnesota 4.26.
yeah,
So they may be close, but definitely you can see that a 4.3 may be quite different from Ohio. Ohio is 3.9. So at least among this comparison, your model should be significant. So it tells that at least one group differs from or other states. That's, I believe, the ANOVA table can. So, but I know that you had conclusions that Maryland, right, it's different from other things,
hmm
right? You want to do that. So then you probably you can't just say, put a Maryland among a bunch to say that. You probably do a pairwise comparison, some additional analysis to say whether Maryland significantly differs from other states pair by pair. That's just some of my comments here.
yeah. Thank you for that. But you are right. Any other questions?
Other questions for you, Sarah? So, Sarah, I would just want to clarify a couple things too. So, can you jump over to your Kachalu tree
Yeah,
slide?
yeah.
Yeah, and can you just kind of talk a little bit? So I know you talked about the mutual information and how they affect each other and things like that, but we don't really have the actual number, the question written out there too. So if you could just kind of talk through maybe kind of what that impact really means, so it's clear to everybody what the power of that analysis. Just kind of go over that real quick again, please.
So basically, what this Chalu tree means is that
Yeah. So like, it's from information theory, right? It helps to visualize
yeah,
what was going on in all your, your Excel tables that you did.
yeah.
But just kind of talk a little bit more about that impact
Got
and yeah.
Okay. So yeah, like I was saying earlier, Chalu trees, the way to read them or the way to get an insight is essentially you would focus on the first level or the second level because the more you go down, essentially improving 23 does not necessarily mean improving 20. It will improve 20, question 13. Improving 23 will have a positive impact on question 24, which is why I try to focus on the top two levels or tiers. And one another thing I found is when I built these Chalu trees, remember earlier I said the CBIS questions were divided into groups. So the first group will be device securement, which had like questions 13, 14, 15, and 16. So I noticed if you improved a question within a specific group, it will have a positive impact on other questions in that group, which is also seen here for 28. 29 is in the same group as that. However, there are some outliers, I would say, but looking at all 16 trees, there's only a couple that have outliers. Majority of them are improving one question in that group will have a positive impact on the questions in that same group.
Okay. And I believe I don't believe I know you like graph that out on the next slide too. So if you want to just put that up
Yes.
so people can maybe digest that a little bit more, and then I will ask too if there are other questions. And check your time too. Okay. All right. I think that is it then, Yipsira. Thank you very much.
No problem. Thank you.